Okay, I certainly hope that this is coming through in a big screen and that I don't need to swap displays. Logarithms. That's what we're about to start studying. And this is a topic that has often given students fits. It's what we will end the year with. I have two very, very fond memories of logarithms besides how to do them. My very first year of teaching was the most popular show on television at the time, or one of the most, was this show called Moonlighting, and it starred Sybil Shepherd and a very young Bruce Willis. I'm a big Bruce Willis fan. So we used to have in our class every Wednesday morning, because on Tuesday nights at, I believe, 9 o'clock, Moonlighting was on every week, and we would have what we called on Wednesday morning the Moonlighting Multi-Minute, and we would take about 5 to 10 minutes at the start of class, and we would talk about the episode the night before about moonlighting. So one particular Tuesday, I gave a test. I usually gave them on Fridays, but this particular week was a Tuesday. And then, you know, the whole class went home, and I'm sure just about everybody watched Moonlighting that night. And lo and behold, we have the next morning, we're about to start logarithms. And what I'll never forget, it was the first year I ever taught logarithms. It was to an accelerated algebra class, algebra 2. It wasn't even algebra 1. It was like one step below pre-calculus. And as we were teaching, as I was about to teach it, the episode the night before, there was this one scene where Bruce Willis on the left and Maddie, Sybil Shepherd on the right, David Addison and Maddie, I don't remember Maddie's last name, but the two of them were walking down this dark hall in a morgue. And there were these perpendicular hallways, and someone flashed a lighter in the perpendicular hallway and said, "Do you know what I don't understand?" And Bruce Willis, ever the wisecracker, said, "Logarithms." Nobody understood logarithms. And I had to laugh, because the next day was the first day of my life that I would ever teach logarithms. Fortunately, I had an amazing high school teacher who taught me a lot about logarithms, and we're going to study logarithms. We're not going to dedicate a really deep digging into logarithms, but we're going to hit it deep in a couple of areas, but not fully deep, because there are areas we're not going to touch with logarithms. So that is the first time I ever taught logarithms, and it always makes me laugh. Years later, teaching another algebra 2 / trigonometry class, there was a girl in my class named Amanda Anello. I would eventually become co-wrestling coaches with her brother Tom, and Amanda was in class one day, and I gave a test, and the unit was typically exponents and logarithms. As you're about to see, they're very closely related. And Amanda, I passed out the test, and within about 15 minutes or so, Amanda, who was never the first one done, oh, and by the way, I should tell you also that she had failed the year before with a different teacher, and they put her in my class. So she had been doing very well. Her average was right around an 80, 82, 83, you know, fine. So about less than halfway through the class, she walks up to my desk and she hands her paper in, and she was never the first one done. And I looked at her test, and every single logarithm question was blank. She answered all of the exponent questions. And I said, "Amanda, you only did half the test." And she goes, "Oh, I don't do logarithms." So logarithms walk in with quite the reputation for them. And I'm here to tell you that I think we're going to get you very good at logarithms. Now remember, it doesn't matter how fast you learn, it matters that you learn. So we're going to start them today, just do a little bit. We're going to go more in depth on Wednesday. We will go no further than what we do Wednesday, but we will also review them, teach them today, teach and review Wednesday, review Monday, then you have your test Wednesday, and then review the following week a little bit more for the final. So that's what we got working with logarithms. So take it as a personal challenge that you understand them, and Bruce Willis did not. What is a logarithm? Well, this is the single most important thing you can understand about logarithms. A logarithm is an exponent. A logarithm is an exponent. Did I mention that a logarithm is an exponent? Now, the reason it's so important to understand that is because once you understand how an exponent behaves, It's a very tiny little step to understanding how a logarithm behaves. The problem is a lot of people tend to think logarithms are this separate entity unto themselves, and they are not. They are, for all practical purposes, they're not identical to exponents, but they're practically identical to exponents. So if you know how to operate with exponents, you know how to operate with logarithms. Let me show you what I mean. This is a typical logarithm expression. It says the log to the base 5 of 25 is 2. So notice, the base we write as a subscript, and I drew a little arrow there to base to remind you that it's a base. And the exponent, because a logarithm is an exponent, the exponent is 2. See, the log to the base 5 of 25 equals 2 is equivalent to the statement 5 squared, or to the second power, is 25. So a logarithm is an exponent. The logarithm, 2, is the exponent. So if you never lose track of the fact that the base is the base, that's pretty simple, and the logarithm is the exponent, it allows you to translate back and forth between logarithm form and exponent form. Try the first row here. Go ahead. Remember, of course, we're doing stop and start. Do just the first row. Okay, so a logarithm is an exponent. So the exponent has to be the x, because it says the log, forget this stuff, is x. So that's saying the exponent is x. Now the base is 3, because that's what's down here, base bottom, makes sense, right? And 3 to the x is 9. The 9 goes the only other place left. Okay, let's try the next one. The log to the base 2 of 32 is 5. What's a logarithm again? Okay, a log is an exponent. So the log to the base 2 of 32 is 5, means the exponent is 5. There's my exponent place. The base is the base. The base of the exponent, 2. The base of this, right here, same thing. And then 32 is what 2 to the 5th is equal to. All right, so now let's go backwards. Let's go from the exponent form to the log form. Go ahead. Remember, a logarithm is a what? Logarithm is an exponent. Go ahead. Okay, and remember, I'm counting on stop and start here, so you can take as long as you need. The logarithm is an exponent, so the logarithm has to be 3. The log is 3. And the base clearly is 10, because that's the base on the exponent. It's the base on the logarithm, because the logarithm is an exponent. The base better be the same. It's consistent. It's one of the beauties of mathematics, is the consistency. And then 1,000. So in other words, log to the base 10 of 1,000 is 3, which is just like saying 10 to the third power is 1,000. Okay, try the next one. Oh, excuse me, I was just yawning there for a moment. So the log to the base 2, there's the base 2, of 1/4 is going to be -2, because a logarithm is an exponent. Okay, let's do a little bit of converting here. Let me see what we got. The log to the base 7 of 49 is 2. Go ahead. What do you think we got there? What's a logarithm? A logarithm is an exponent. So another way to say this is 7 squared is 49. 7 squared is 49. Let's see, you try the next one here. The log to the base 5 of 125 is equal to 3. Okay, just write your answers down, because eventually we will get to all of these answers. Next up, the log to the base 4 of 1/4 is -1. Oh, we do 3 across, then we do the answers. Okay, so let's take a look at the first one. We said 7 to the second power, 7 squared is 49. Remember, a logarithm is an exponent. The logarithm is 2. 2 is the exponent. Next up, the logarithm is 3. 3 is the exponent. The base obviously is 5. How would that relate to the third one here? So the base is 4. The logarithm is -1, so that's the exponent. So 4 to the -1 is 1/4. All right, let's try the next one. Log to the base 9 of 81. Then the next one, log to the base 27 of 3. And the third one, log to the base 4 of 32. Answer those three, and then we'll give you the answers to all three of those. Okay, so remember, a logarithm is an exponent. In this case, we're trying to figure out what the exponent is. So 9 to what power is 81? Well, 9 squared is 81. You could get a common base here, which would be a little bit cleaner. But to be honest with you, I found these examples online and I just copied and pasted. So next one, the base is 27. So 27 to what power is 3? Well, 3 is the cube root of 27, so it's to the 1/3 power. And last, 4 to what power is 32? This is better off. The best way to do this is to get a common base, which is 2. 4 is 2 squared, 32 is 2 to the 5th, and then put an x here because you don't know what it is. So 2 to the 2x is 2 to the 5th, 2x is 5, x is 5 halves. We did a lot of work like that. So I think if you didn't understand me the first time, if you go through the second time, I think you'll get it down pat. All right. Check it out. I would suggest, because most people don't think in logarithmic form, they think in exponent form, I would suggest converting to exponent form and then figuring it out. Go ahead. Okay, so exponent form would say the base 8 is 2. Logarithm is an exponent. To the 2/3 is x plus 1. So let's just figure out what 8 to the 2/3 is. Fractional exponent. The roots of the tree are down. The power is in the leaves. The cube root of 8 is 2. Squared is 4. So I get 4 is x plus 1. And subtracting 1 from both sides, x is 3. Okay? So hopefully you're starting to get a little feel for these logarithms. Remember, today is not the only day. Don't let them frustrate you. And if you need to, rewind this streaming video. Okay, next up, which points are on the graph of the logarithmic function? Now this is what you need to know. If a point is on the graph, it checks. If it's not on the graph, it does not check. So let's do them one point at a time. Let's plug in the point 5, 3 into the equation. Remember, 5 is your x value, 3 is your y value, and see if it checks. Go ahead. You're, of course, doing stop and start. So, does 3, because that's the y value, equal 2 times the log to the base 3 of 5 minus 4, which is 1, plus, of course, 5 at the end, because that's what it says there. That this teacher seems to make some sloppy mistakes, too. All right. So, 5 minus 4 is 1. 3, remember, logarithm is an exponent. 3 to what power is 1? 3 to the 0 is 1. So the log to the base 3 of 1 is 0. 2 times 0 is 0. She divided by 2. Oh, okay. Oh, I see what she did. She subtracted 5s and got -2. Then she divided by 2 and she got -1. And then she's saying, does the log to the base 3 of 1 equal -1? In other words, there's your base. Does that to the -1 power equal 1? No, it does not. So it does not check. So what was done here is they solved for the log. Just like we would solve for y or solve for x. They're solving for the log first, and then they're checking. I was going to check it in the original equation, but that's okay. You can solve in the derived equation. Better off in the original, but we can go with the derived because that's why she's doing it. Let's try the next one, see if the 0.77 works in there. Go ahead. Okay, so substituting the values, and this is kind of weird. Most people solve first, then substitute. This teacher, he or she or whomever it is, did the opposite. They substituted first, then they solved. So subtracting the 5 and you get 2, then dividing by the 2 to get 1, and then substituting, of course, the 7 in here. 7 minus 4 is 3. So does the log to the base 3 of 3 equal 1? Well, logarithm is an exponent. There's your base. Does 3 to the 1 equal 3? Yes, it does. Check. That is a point on the line. Try the next one. Okay, next up. Again, solving, substituting in first the 9 for the y, the 13 for the x. Subtracting the 5, you get 4. Dividing by 2, you get 2. And over here, the log to the base 3 of, when you substitute a 13, 13 minus 4 is 9. Does 3, because the logarithm is an exponent, that's the base is 3, to the second power equal 9? Yes, it does. It checks. So these two are circled because they check. The first one does not check. One last thing for today, and this is just kind of setting things up a little bit, just a little bit of our work here. Here are your exponent rules and logarithm rules. Now, a logarithm is an exponent. Since a logarithm is an exponent, you can expect it to behave the way that exponents behave. So, for example, here's your exponent rules. If I just had a to the m times a to the n, you add the exponents, right? So, for example, if I had x squared times x to the third, I would get x to the fifth. You add exponents. Well, look what you do with logs. When I'm multiplying, I add, just like you add the exponents. So when you're multiplying common bases with an exponent, you add. When you're multiplying, as soon as you have logs, you have a common base. You add the exponents. When you're dividing, you subtract. When you're dividing, you subtract. So you subtract the logs. And next up, when you're raising to a power, you multiply. When you raise a power to a power with logs, you also multiply. The way we write the multiplication is to put the number in front, or the exponent in front. So these logs follow the same sort of rules we've been going over with exponents already. So let's take a look at the first one. The log of 3m, remember, when we're multiplying exponents with the same base, we add them. So I'm going to add log of 3 plus log of m. So the log of 15x is the log of 15 plus the log of x. You try the next one, log of 25y. That'd be the log of 25 plus the log of y. Try the next one. That would be the log of a plus the log of b. And the last one. The log of 5 plus the log of a plus the log of b plus the log of c. You're multiplying all of these things. They're exponents being multiplied, and just like in this top rule where you have the same base, and the logs are common base, it's a base of 10, you're going to multiply, you're going to add the exponents, so you add the logs. Log of 5 plus log a plus log b plus log c. All right. That, folks, is where we're going to leave today's lesson off.